Welcome to RCR Wireless News. I'm Martha DeGrasse, and our topic today is diameter signaling in mobile networks. I'd like to introduce you to our panelists for today. Sue Rudd is Director for Service Provider Analysis at Strategy Analytics. Sue, thanks so much for being here today.
Thanks. Hello.
Chuck Wesley James is Senior Product Manager at Sonos, our sponsor today. Chuck, thank you very much for joining us.
Well, thanks for having me.
Susan Hackman joins us from Oracle, where she is Senior Product Manager. Susan, thank you for being part of our webinar.
Thank you.
And Peter Veenstra is former Chief Architect at KPN. He has recently joined NetNumber, and today he joins us from LTE World Summit. Peter, thanks for making the time. I know it's evening for you.
Thank you very much for joining me.
And I'm Martha DeGrasse with RCR Wireless News. I'll take a quick minute to tell you about RCR Wireless News. We are a premier news source for the wireless communications industry. We try to keep you up to date on carrier, distributor, network, handset, and telecom software news. Follow us on the web at rcrwireless.com and on Twitter at RCR Wireless News. I'd also like to direct your attention to an RCR Wireless News feature report on the topic of diameter signaling. This is available on demand on our website. Click on the Feature Reports tab. Key takeaways from this report. Diameter signaling is key to LTE networks and to IP elements in 3G networks. Diameter signaling traffic is very much on the rise. Traffic management and load balancing are traditional use cases, but policy and charging are the fastest growing use cases. Diameter messages can yield network intelligence, and we will talk about that today. And carriers are interested in virtualized diameter controllers. Very quickly, a history of diameter signaling. It did evolve from the radius protocol in IP networks back in the 90s. In mobile networks, diameter succeeds SS7, and as traffic on mobile networks increases, diameter signaling can increase exponentially because each mobile device generates multiple signaling events when it accesses the network. Diameter signaling controllers involve diameter routing agents, diameter edge agents, and usually an interworking function, IWF, to enable communication between different network protocols. Now, with that brief introduction, I'm going to hand it over to Sue Rudd at Strategy Analytics for some more in-depth information.
Thank you very much, Martha, for that quick introduction. I'd like to make a couple of points about the role that diameter plays, because I think signaling for the first time has become an exciting part of how operators can add value. It's not just a high-performance solution to solving how you do all the connectivity and resource allocation. It is actually a capability in its own right for actually being part of how the operators both optimize performance and eventually increase their value to the users. What we have on this chart is a brief escalation over time in network functionality, showing from the bottom left how signaling capabilities are just basically managing calls, but moving into the world of network function virtualization, and a world where we aim to simplify addressing and traffic management in order to deliver higher performance. And as we move forward, what is called service orchestration, where I can dynamically allocate resources to each service and assign different users to each service. Over time, we'll see more and more services that optimize subscriber profiles for personalized services and that link in real time to policy control mechanisms. And overall, we'll see a much greater evolution towards flexible addressing and traffic management. But these kind of functionality has to be mapped, as we see on the lower ladder, if you like, on the bottom right, that matches the signaling functionality to this new world as we move to managing network-wide signaling, user-defined networking being one of the things that operators want to achieve, where an individual user can actually request a given service logic and assign themselves the required elements. We expect to extend signaling and control planes as part of the software-defined networking, and we think that is going to be one of the most important trends in the signaling over time as that control plane capability becomes the way in which operators optimize resources. And we expect all of this to be increasingly real-time as real-time state machines evolve across the network, and some challenges are going to occur in that space. Next slide. Just to put this in context of how do we actually manage domains of services, we've grouped the services into 4 types. We have a traditional, at the bottom left, we have the application services, the conventional clouds, or now conventional cloud services, which would represent most of the applications that end users are familiar with. But then we have application domains that relate to the network functionality. In particular, the operations support domain, which may include the real-time billing systems and mechanisms for updating user data plans and so on. But we also have some of the other OSS functions for administering service provisioning and actually activating users on the network. In the middle, we show the family, if you like, of profile databases. Historically, those were HLRs for the 3G systems, and now we have HSSs with the subscriber profile repository to mirror the data for real-time access. And then, of course, we have the equipment identity register and a number of other databases that allow you, both the operator and the equipment, to be identified in real time as part of a service activation process, as well as the ongoing operations tracking. And then at the top right, we have a whole policy domain, which itself can add significant value, both from the policy rules engine, as well as from the traditional service control points that we use in SS7. Next slide, please. As we go forward, we're going to get into some complex problems. And I just wanted to show a diagram that shows how all the different connectivity. At the bottom right, you see some of the traditional recognizable elements that you're familiar with in the IN and IMS world, with the CSCF functions of various types, the BGCF, and all the different elements that we're used to talking about, including these signaling transfer points that you have, the old-fashioned STP for your SS7 network, shown here with the red dots connecting to all these domains that I just mentioned. But now we have the diameter signaling controller, which also has to have connectivity. And the basic message of this chart is, as we go forward, we're going to have diameter, we're going to have SS7, we're going to have the enum connectivity, we're going to have DNS, and we're going to have SIP interoperability. So the fundamentals of networking that occur from the signaling network's perspective are increasingly complex. And not only do we have dramatic increases in signaling traffic, but we will also have a dramatic increase in complexity. And we're here today to talk about some of the solutions that people are talking about as we try to approach this new world. Thank you, Martha.
Thank you, Sue, very much. Now, at this time, I'd like to turn the presentation over to Chuck Wesley James from Sonus, our sponsor, and he will take us through a brief presentation. And after that, we will get into discussion of the specific use cases of diameter signaling, as well as virtualization of diameter signaling. Chuck, thank you very much. It's all yours.
Okay, thanks, Martha. Let's go on to the next slide. So Sonus Networks is a provider of real-time communications security services. There's a variety of different ways that works into the LTE network and the IMS core. You know, Sonus itself has moved from voice over IP and SIP, where it is the fastest growing SBC company today. It moves over 1 billion minutes of voice traffic per day. And on the SS7 diameter side, which is newly acquired from PT Systems, the SS7 SDPs and DRAs share the same infrastructure, and we have over 1,100 installations around the world, branded as PT or Sonus, and again, working at that same platform works, SS7 and diameter. Within the networks, there is a bit of mix and match going on in terms of which functionality you wish to have on which platforms. So SS7 and diameter is quite a common mixture. We're also finding that we'll be putting on the DEA functionality right with the SBC. The SBC has some hardware chips we'd like to take advantage of as a platform. And then we'll go forward into the virtualized platforms, which we'll talk about a couple slides later. Let's jump on to the next one.
Next slide.
So in terms of diameter and the SBC, I wanted to sort of break that out because sometimes we talk about doing our LTE networks and we speak a lot about diameter but forget the SIP side. And if you remember from your SS7 days, the diameter side feels a lot like the TCAP side of the house, and SIP is still the ISUP. So as you're building out those networks, I want you to think about how the SIP side still needs to come into play to get that full phone call working. Whether you're doing SIP or H.22323, it's still going to be an important part of what you're doing. Today, we currently have our diameter and our SBC in separate platforms. In the next few months, you're going to see those combining into one platform.
Next slide.
Please. So looking at virtualization, virtualization is our current industry buzzword. I think it's a great topic. I'm more of a software person than a hardware person, so I like it. But it's also funny because we've been using it in the industry for a long time. We started out with purpose-built hardware a long time ago, and then we started having putting more than one functionality onto that piece of hardware. We first started out with multiple aliases. In the SS7 side, these were referred to as capability point codes, or doing multiple signaling gateways onto the platforms. Then we started moving into multiple instances where we have multiple virtual STPs sitting on one piece of hardware. But it's still one purpose-built piece of hardware at that time. The next step, which is coming now, is to put those as VMs on commercial off-the-shelf hardware. I think that's a great step. And then moving forward, we'll start seeing VMs on shared hardware and going on to VMs to the cloud. So there's been an evolution of the industry that's been going on since I've been in the industry, and we're finally getting to the cloud services now. In terms of what we're doing, putting SS7 in diameter onto the same platform as it is now, joining that with our Sonos SBC. The commercial off-the-shelf version of that is also available, and we ourselves will be moving into the cloud version of that for greater expandability. So our vision going forward for virtualization is to allow one piece of system, I don't want to call it a piece of hardware now because it is a cloud, and have the policy exchange server, the SBC, the DSC, and the SS7 functionality all working cohesively. Whether those are within one virtual machine or within one cloud is going to be a network architecture decision for each network to figure out how they want to design that. So that's my very brief introduction to what we're doing here at Sonos and where we're moving. Thanks for the time.
Thank you very much, Chuck. We're going to get into the use cases now. These are the use cases that we plan to try to cover today. We are taking questions from the audience. We may or may not have time to get to those, but we will try to forward those to the people on the webinar. So please do send your questions using your GoToWebinar control panel if you have them. The use cases we will discuss today include traffic management and load balancing, roaming, PetNets and Wi-Fi offload, VoLTE, OSS, BSS, policy and charging, and then we will discuss virtualization of the diameter signaling control function, although I think it will have already come up in the discussion before. So we're going to start with traffic management and load balancing, which is the traditional use case for this protocol. And Susan, I think you're going to start us off with a little bit from your background at Tech-Elec about why this is the traditional use case and how it's changing.
Thank you, Martha. Yes. Yep. When we look at traffic management and load balancing, it's really, truly about simplifying the network. If you go back to that network diagram that Sue Rudd put up a moment ago, you can see when you're interconnecting all of the servers and clients, it gets very complicated very quickly. And without a centralized diameter routing function in the network, how would you do load balancing? How would you route around a failure? How would you manage congestion control or do topology hiding? So you can see with a centralized diameter signaling controller, you have a central point for doing a secure interconnect to other networks. It's the perfect vantage point to pull monitoring information from and actually make orchestration decisions at that point in the network. You can do load balancing and also do congestion control. Interoperability and interworking can all be done at that central location. And you can see how this would even become more critical in a virtualized environment. In a virtualized environment, those interconnected peers are going to be growing and contracting as the network needs change. So you really need a central diameter device in the center of the network to orchestrate all of that traffic and all of those connection changes in that virtual environment. It's really all about supporting network resiliency. You want to avoid failures, you want to be able to route around failures or congestion areas, and you want to be able to gracefully bring back network elements as they come back online.
Thank you. Now, you mentioned interoperability. Chuck, in your conversations with operators, are more and more mobile operators bringing more and more different types of equipment into the network?
Yeah, there are different types of equipment going on to the network, and sometimes we're finding that those pieces of equipment, while they are adhering to standards, have some little differences that need to be made. So we find ourselves as a mediator between the two, both in terms of changing those AVPs and diameter messages as they pass through, but also as a neutral third party to help in the troubleshooting between the two. So you don't get into two vendors saying he said and they said, and we can be a neutral third party and look at the messages that each are actually sending. Also, in terms of interworking, we're seeing a lot of interest in 3G to 4G roaming and vice versa. And the roaming back and forth with SS7 is proving to be an important aspect.
Right. Can you just give us a brief overview of why diameter is so important when roaming?
Diameter is the connection for roaming, and it's those diameter edge agents that are taking place. So it's highly critical. Roaming itself is sort of interesting. It's thought of as, sometimes the carriers look at it and say, oh, I need to buy an edge agent, but I almost, and it's a capital cost, but I am also finding some carriers are looking at this as a revenue stream, and they're starting to offer these diameter edge agents on behalf of other carriers. So they're becoming small-scale IPX providers.
Okay, that's very interesting. Now, Peter, I know that you're in Europe, and I'd like to hear your perspective on recent changes there and how that's going to impact roaming and diameter traffic in particular.
Yes, in Europe there are strong demands from the politics that prices, the consumer prices for roaming have to go down rapidly. Finally, that will have an impact on the technical solutions. For the moment, however, we don't see that happening in the technology itself yet. The local breakout, that is an efficiency measure by which roaming customers generating internet traffic, that will be breakout in the roaming network. It's not happening yet, and also this week in LTE World Summit, that was being underlined by both an operator as well as an intermediate carrier, that they don't see that happening very fast. So local breakout is not happening that fast as maybe some people have predicted in terms of data, but in terms of voice it will even be slower, because for roaming voice over LTE type of policies, operators have not yet come to an agreement about the charging. So the effect of that it will be strange enough that although diameter will be growing fastly in volumes, number 7 will grow as well, because with the intensive use of smartphones and the volumes of signaling that is being created by smartphones, still the traditional voice will be making use of number 7 roaming procedures. So that is, I think, the situation of today, that although the political people are asking for something, the technology is not going that fast as we may have predicted. And it will be seen in the coming year, I think, how things will be changed by this regulation requirements.
Okay, so people are getting the message that the local breakout may not be feasible as quickly as some people may have thought, right?
Yeah, and the voice over LTE roaming, that looks to be even slower than we expect. It's also being known that voice over LTE is only having a very low uptake. There are now some customers using voice over LTE in their networks, but it is far from using voice over LTE also for roaming customers.
Okay, well, we'll need to keep an eye on that. Thank you. So we're going to switch gears a little bit and talk about HetNets and how Wi-Fi and small cells can impact diameter traffic. And Sue, I think you're going to start us off on this part of the discussion.
Yes, thank you, Martha. HetNets are usually thought of as being very much about the RF domain, where we have a 3G network that may be overlaid with an LTE network sharing part of the spectrum or even at a different frequency. And then increasingly we're now having multiple frequencies where the same protocol may be running on multiple of those different frequency bands. But it's getting increasingly complex from the RF signaling point of view. But people don't always talk about the impact on the core network signaling that's associated with mobile roaming across these heterogeneous networks. And as we introduce small cells, the problem gets even more severe. There's a very good recent paper by Alcatel-Lucent on the challenges of HetNets and the impact on core network signaling and how to minimize that. I think we need to think in our network architectures about how you have relatively aggregated traffic back to the core so that you don't create a signaling tsunami as there's a lot of mobile-to-mobile handoff. And then eventually we expect Wi-Fi to become part of these networks, probably starting around 2015, where Wi-Fi...
I'm sorry, 2015? I missed that.
We expect Wi-Fi to become part of a small cell infrastructure in the 2015 timeframe, as just about every small cell that's getting deployed next year will incorporate the option to become a Wi-Fi access point.
Right.
So Wi-Fi suddenly becomes a part of the HetNet in that, but unfortunately it's not there today, and we still have to deal with some other protocols. Susan, I think you have some comments on that.
Right. So if you look at this from a diameter signaling controller perspective, the introduction of Wi-Fi offload or Wi-Fi HetNets puts a requirement onto the DSP to support diameter to radius interworking. So we're back to another interworking use case in addition to some of the other ones we've discussed. I also see that for fixed mobile convergence, we'll see session correlation requirements for policy messages as well that will drive the need for diameter to radius. That's another use case for that interworking function. And then finally, just for pure Wi-Fi roaming, we could conceive of the necessity for a radius router, very similar to a diameter router, to handle Wi-Fi roaming. So again, all of these use cases drive an interworking type of function onto the DSC.
Now, you mentioned a radius router, but what about going the other way and the Wi-Fi access points using diameter? Do you think that will happen or not?
Someone else may want to comment on that. I don't really have a strong opinion on those access points, whether or not they'll go diameter or not. Currently, Wi-Fi is the interface would be radius.
Right, yeah, I don't know if anyone else has an opinion. I have heard that from at least one company in the space. Not that it's happening, but that it will happen. But I guess we'll have to wait and see on that.
Probably a little longer in the future, probably in 2017 or so.
Okay, let's move over to VoLTE. And Peter, I know that you already got us started on this topic. Here in the U.S., I know carriers are trying very hard to get there, and there's a lot of interest and curiosity about it. Chuck, I'm sure that you're talking about it a lot with operators, and it'd be great if you could update us on what's going on in your conversations around VoLTE.
Sure. Well, that first question you got up is an easy one. Will diameter completely replace SS7? Yes, but not before I retire. There's still a lot of SS7 out there. And VoLTE is obviously a big topic for us because we do a lot of SIP work and H.323 work. I think as we're going towards VoLTE, it's in terms of equipment, it's nice if you can have a piece of equipment that's able to move resources from one to the other. Because certainly as a carrier, as you move more and more of your services from traditional SS7, going over to SIP SS7 diameter, sorry, SIP or diameter-based services, you're going to find yourself with equipment that's now freed up. If that's general purpose serving equipment, then your virtual machines can take more and more advantages as you shift from one to the other. If it's purpose-built equipment, then being able to handle both SS7 and diameter and potentially SIP in the same place also allows you to shift those resources as it's going forward.
Okay, great. And Sue, I think you've talked to a lot of operators about this too. What are you hearing?
Well, I'm hearing that there have been some recent issues, and a couple of the operators have recently announced. EE in the UK, for instance, said that they did not yet believe that the performance of VoLTE was up to the traditional voice service. So they will, in fact, be continuing to run a hybrid 3G voice network with their broadband data LTE network. So we expect to see a lot of interworking and a lot of hybrid networks. Some of the US operators, like Sprint, I believe, have also experienced some real slow fallback delays when VoLTE has to interoperate with a phone that's not on VoLTE. And the real challenge for VoLTE is getting to all of the phones before Chuck retires.
So lots of hybrid, lots of interworking. What are the implications here for equipment vendors, Sue?
I think the biggest implication is how do you do this without having introducing significant delay in the network architecture and without imposing lots of legs of signaling traffic that do not in fact get paid for by anyone. So we really need to optimize the architecture of the network to minimize the signaling load created by VoLTE interworking with traditional voice.
So a lot of planning ahead and a lot of simplification. Now,
Correct.
Peter, I know that simplification of the network is an important theme for you, and I also know that you've done a lot of work around OSS BSS. So perhaps you can start us off with our conversation of how diameter impacts this.
Yeah, maybe if you allow me on voice over LTE.
Oh, sure.
This week at the LTE World Summit, it was also for me new that from two sources, from an operator, Everything Everywhere was being mentioned already. That was the operator in England, and also from BICS, the IPX provider in Belgium. Both had the same statement that they foresee that number 7 is not on its peaks, that they foresee that in 2017 the peak of number 7 traffic will be reached, and that we still have to count for an increase of 20% of the signaling traffic in number 7. And with regard to the European situation, I would like to add that in contradiction to, for instance, the US, where now voice over LTE is getting into the networks, that is because of coverage, that is because of the CDMA networks that are legacy and needs to be replaced. That in Europe, most of the operators are in a very good shape with their 2G, 3G networks, and those networks are still working perfect, but also they have experienced that circuit switch fallback is performing far better than was being predicted previously. So there is not a need in Europe at least to go very fast with voice over LTE, because the voice in the existing 2G, 3G networks is of an acceptable quality, and the delays in call setup are not that big as being predicted, and the customers are not complaining. So I think that is also to be known, that voice over LTE is not going that fast.
Right, so the customers aren't asking for it. I know here in the US we hear a lot of talk about how VoLTE will enable new opportunities for the operators to offer new services to customers. Are the European operators talking about that?
Yeah, they are talking about, for instance, RCS, which is already being introduced in some European networks, and already for some time in, for instance, France for a couple of years, already more than a year in Spain. The uptake is not according to the expectations. because for other applications like messaging, file transfer, and that kind of things, the people are more accepting the over-the-top type of applications, and it seems that the operators are missing the opportunity and have missed the opportunity in the previous years. So voice is the only application today where they are concerned about, and in Europe they are quite satisfied with the existing mobile circuit switch solution, and they won't touch it when it is operating still very good. And you also have to, and that brings us to the next topic, OSS BSS, all the consequences voice over LTE will have in the OSS and the BSS, at least from the legacy networks. And when we are talking about OSS and BSS, then that is possibly even an area of more concern than the signaling area within the operators. The OSS and the BSS is the most complex and cost intensive area nowadays in operator land, and it is really also a very big hinder in service innovation. And that's why I think that when vendors, as my company NetNumber, are able to offer solutions where a lot of functions can be combined in one platform, that simplicity is being reached, and that the things that are being orchestrated in the OSS and BSS becomes simpler because it is taken care in the signaling domain already. And I think there you see also the interest operators are showing in the solution my company is offering, and other companies that have a proposition where a lot of functions are being combined, and particularly when you can offer a solution where technologies are being bound. Number 7 with diameter, with IMS, and with enum. Then you can make a real distinction and make a real solution to the operators.
Okay, thank you. Now, Sue, what would you say about that? I know that you've spoken in the past about the need to separate different types of traffic. Peter's talking about simplification and unification. How does that all fit together?
Well, I'd like to give a plug for the TM forum work that's being done under a thing called Project Zoom, which is designed to be zero-touch OSS. But as you get into administration side of it, obviously there are the human aspect of OSS where you have a real user asking for a new service. But we increasingly see the focus of OSS needing to be on that part of the network that's operating in real time, where I'm actually doing what's called service chaining in the SDN world, where I'm actually defining a service logic flow through my virtualized elements to define a new service. We used to call it service creation, but then I also implement that service logic flow with what we used to call a service logic execution, and we activate the functional elements in the network elements in real time. And this is the role of the real-time OSS aspects. And it really needs to be optimized very differently than you optimize the administrative service functions for human beings. You're really activating the kind of element management in real time, and this is all about network orchestration going with service orchestration in the NFV type of language, where the two have to be very tightly coupled in order to activate new services. And this gets to service agility, which is the other hot buzzword that the operators are really looking to really get high-performance operation support systems that lead to the ability to provision services very rapidly.
Very rapidly, everything in real time. So I think it goes without saying that these trends greatly increase the volume of traffic and the amount of signaling traffic in particular. So Chuck and Susan, I'd like to ask both of you what you're hearing from operators just about volumes of signaling traffic as they do try to provision real-time services. Chuck, let's start with you.
Well, yeah, the volume of signaling traffic is high, certainly, but it's nothing that modern equipment isn't able to handle. And Susan earlier touched on the topic of throttling, flow control, congestion control, and these are going to be critical in any of the network elements, especially in a diameter signaling controller acting in the middle of the network. We want that central point to be the place where it's going to stop a signaling flood before it happens. And there's no reason that that system can't be the one that is able to be provisioned with how much traffic a certain point can get or should send. And it's a great logical place to control that signaling storm. But realistically, software and hardware have gotten a lot better over the years. We can handle millions of messages per second in terms of a diameter signaling controller or a SIP proxy server. We just need to be able to make sure those end units can also handle it. And we need to be able to control that and throttle it.
Okay, thanks. And Susan, do you have anything to add on this before we move on to policy and charging?
Yes, Martha. I would like to touch on just a little bit different perspective. As you can imagine, Oracle is working with some of the VoLTE rollouts that are going on in North America, and we work with some of the largest operators in the world. And the experiences that we've seen, for instance, for this OSS BSS traffic, the second bullet on your slide there really does identify what a lot of operators are doing. They are creating completely separate networks to separate the different types of traffic that they see within their network. And a point I wanted to make on sort of the VoLTE and what we're seeing from a signaling perspective, since we're really talking about diameter signaling here, is that in our experience with customers, what we see as the impact to diameter signaling is a need to do session correlation between IMS and LTE networks in order to apply the same policy. So it's a policy DRA function. You want to be able to apply the same policies to a particular subscriber if they have multiple sessions at the same time. So that's the biggest impact we see on the VoLTE rollouts that we've been working with operators on.
Is there a lot more of that going on, people with multiple sessions active at the same time? I would think there might be a growing trend in that direction.
There certainly is, and that kind of gets into our policy discussion, which I know we're going to touch on in another slide or two. But from the VoLTE perspective, definitely there's a session correlation requirement between IMS and LTE networks.
Okay,
so
great.
I guess that segues right into policy and charging.
Yeah, take it away.
Okay, well, you know, from the heritage here at Camient, Tekelec, and now Oracle, we've been involved in the policy management business for quite some time. And it's really the new service models that users and operators, or primarily subscribers, are demanding that's really driving the sophisticated policy requirements. You hear about casual usage or service tiers, things like parental control, mobile video, creative packaging of services, multiple access and roaming usage. All of these types of services and service models are driving sophisticated policy requirements into the network. And those policy messages, of course, are diameter, and that's driving up the diameter signaling requirements within the network. So I'll take the second bullet about PCRF binding and why it's important. The importance is, as a subscriber opens a session, their policy is applied from a particular PCRF. So all subsequent messages of that session need to be directed to that same PCRF to get the correct policies applied. And then on top of that, we have the session correlation, which means that when a user has multiple sessions at the same time, whether it's a chat and a video download or some other type of sessions, all of those messages for each of those concurrent sessions needs to be bound or directed to the same PCRF so that the customer gets a ubiquitous experience and all of their policies are applied in a uniform manner across all the sessions.
Okay, great. And I know policy and charging are areas that we hear a lot about with respect to virtualization. Chuck, how do you think these will change as carriers do try to move more policy and charging to the cloud, really?
Actually, and it ties into the binding discussion. as we're moving the PCRF functionality into the cloud, the communication between virtual machines is going better and better. And I'm finding some cases where the PCRF is sharing that session ID back and forth between itself on remote geographic locations, which means that the diameter signaling controller does not actually have to do the binding. I think we'll see that more and more in the future, which I think Peter, with an interest in simplification of networks, is also probably interested in. By moving that functionality out of one element closer to the element that actually needs the functionality, we're finding a change in there. So that functionality can be right with the PCRF in its virtual machine, or with a separate DRA functionality or diameter signaling controller acting as that functionality doing the binding. But using that stuff in the cloud means we can locate that near is a strange word in the cloud, but near the elements that actually need that to simplify the rest of the network and separate that out.
Okay, great. And what about actually moving diameter signaling to the cloud? Are carriers asking for this?
Yeah, they are. And we do, as vendors, need to step back and remember why carriers are asking for this. You know, I'm a software person. I think it's really interesting technology, so I'm into it. But carriers aren't into the fun of it. They're into it because it's saving money. It's saving OpEx. It's allowing them a faster time to market. They're able to reuse hardware that they already have and are using in their networks. So as vendors, it's our value add going to virtualization is to let the carriers use the infrastructure they already have and already have agreements with. And I think we can take that further by using open APIs to our virtual machines so that other applications can talk to our virtual machines, the OSS systems in the back end, or downstream monitoring systems can talk to our systems in a more seamless manner from that cloud.
Okay, great. And one other thing I wanted to bring up is the the order of operations. I think that there's a lot of talk about different parts of the network being virtualized. Do you think that other parts of the core need to be virtualized before diameter signaling control can be?
Well, you know, as a carrier is building out their network, it really depends on a business case what's going on. Certainly, this can all be virtualized. We run SS7 in a virtual machine as well as diameter. Certainly TDM links are an issue, but and I don't think we're unique in that fact. So in terms of as a carrier, what do I need to virtualize? The carriers are going first to off-the-shelf rather than to cloud as a starting point. And I'm finding the carriers are first using off-the-shelf hardware for a single purpose. So they are buying a server and putting their diameter signaling controller on that server only. I think the next step will be as they get more comfortable with that, putting their DSC and their PCRF on the same piece of hardware moving forward. But for now, there is a go slow approach, and it's commercial off-the-shelf hardware, but the same hardware throughout their data center, and but it is dedicated to that virtual machine that's running on it for that purpose.
And there's not a problem with the diameter signaling control function running well on OTS hardware? That works fine?
Yeah, that works great. That's it works well for the design of diameter too.
Yeah.
Susan, I think I hear you chiming in.
Yeah, if I could comment on that for just a moment. Just from our personal experience, a lot of the RFIs and RFPs that we're seeing is operators are looking to virtualize the EPC first for their reasons. They want to, they're looking at the core as probably the easiest place to implement virtualization into their network. And from a diameter signaling controller perspective, the requirement and the need for a diameter signaling controller actually increases with virtualization. I mentioned that when we first started talking about these use cases, because peers will be growing and contracting and being added and being removed on a more dynamic basis ultimately in a virtualized environment. I don't anticipate that the DSC itself will be necessarily growing and contracting, as dynamically perhaps, but it really facilitates the rest of the virtualization of the rest of the network. So it's really the orchestrator sitting in the center of the network.
Okay, great. Yeah, and I know that that's something that you have presented a lot, and for those that are interested in this topic, I refer you to some of Oracle's presentations on the diameter router as an orchestrator. We have had some good questions from the audience, way too many to take, but there's one that popped out at me on how OTT in general will affect diameter signaling, and that is a broad question, but we haven't had much of a chance to discuss over the top. I know, Peter, you brought it up a little bit, but does anybody have any thoughts on how OTT traffic fits into this picture?
Yeah, well, it is partly related to virtualization. I think that when virtualization is being used by operators, then operators are more and more starting to use the same type of equipment and the same type of processors that the over-the-top parties are already using. And so then the technology difference between, say, the telecom world and the OTT world is disappearing finally, and that brings both business areas closer together, and that finally will offer a quite new type of way of operating. That the over-the-top parties can start to use the hardware resources that the telecom operators have in their networks, and by that the hardware power that the over-the-top parties are needing is coming closer to the customer finally. So there, I think finally you see the bridging between the two different worlds, and then also the difference is starting to disappear.
That's a great point. Thank you very much. Now, one other thing that I'd like to discuss before we run out of time, as diameter does become more cloud-based, I think maybe there is an opportunity for operators to extract value from these diameter messages and gain more network intelligence. Chuck, have you seen that at all, or do you think that operators are starting to think about that at all?
Yeah, they're looking at it as a way of network intelligence, finding out who is where of their customers. And as I mentioned earlier on, they're looking at these diameter messages as a revenue stream. So that's the traditional IPX providers and the carriers who are starting to offer services on behalf of their competitors or their partner carriers, and turning the diameter message stream with full monitoring systems into a revenue stream for themselves.
Okay, great. And you did mention that you see diameter signaling running great on off-the-shelf hardware. And do you think that, you know, if we got together on this topic again in a year, that we'd see it running from the cloud, or is it too soon to know about that?
Oh, I think you'll see some of the leading carriers, particularly in the States, going towards a cloud-based service. I don't know if we'll see the full cloud in the network. I suspect we'll see one or two smaller scale deployments within large carriers doing that. They're certainly moving that direction very quickly.
Yes, it'll be great to watch. Okay, Chuck, any closing comments? We're going to come back to each of our panelists one more time before we run out of time here.
Yeah, I think this is a great place to be right now. I'm really excited to be in the diameter space, and you know, the adding of the other network elements that I now have with my larger company. So I have SIP and H.233 along with it. It's a pretty exciting point in the industry, and I'm excited to see what happens over the next 2 years.
Okay, Chuck Wesley James, Senior Product Manager at Sonos, our sponsor today. Thank you very much for sharing your perspective with us. It's been really good.
Thanks for your time.
Susan, do you have any final comments?
Sure. First of all, I'd like to thank you for inviting me to this discussion. It's been very enjoyable and insightful. And just as Chuck mentioned, you know, this is a very exciting place to be now in a diameter environment. It's been very thrilling over the last few years, and I'm looking forward to a lot of the changes to come. And as operators virtualize their networks, Oracle really wants to play a major role in that area. So thank you again, Martha. I appreciate it.
Thank you. Okay, Peter, thanks for joining us from LTE World Summit and sharing a lot of really current information with us. Do you have any closing comments?
Yeah, well, thanks for inviting me to join this webinar. Well, we have discussed a lot of things today in context of diameter, but I believe that those statements can also apply to the other types of signaling, because it is all doing the same type of tricks in the networks. And the virtualization technologies that are now coming available are offering very big opportunities for companies like me, where I'm now working in net number, to make great solutions to the operators to simplify their networks. Thank you.
Thank you very much. And Surad, thank you very much for being our analyst today. Do you have some final thoughts to share with us?
Well, just a final thought going forward on, as we put all this traffic growth into the diameter network and into other signaling networks, and as Peter mentioned, SS7 continues to grow with all this interworking. But let us start thinking about these signaling networks as a network in its own right, with a multi-protocol interworking, but think about all the security, provisioning, and indeed virtualization of all the signaling networks as a network to be engineered and managed, rather than just a useful control mechanism for the transport network. And as we evolve into an SDN world with a control plane that is truly separated from the actual data transport plane, we will, I think, increasingly see some opportunities to translate that into revenue, where the signaling network was viewed as an expensive overhead before. Now it's a real source of value for the operators.
I hope that that's right. I think that is perhaps the most exciting area here. Well, thank you all very much for being here. It's an interesting topic. We hope to come back to it. Diameter signaling in mobile networks has been our topic today. I'm Martha DeGrasse for RCR Wireless News. Thank you again, and this will conclude the webinar.